Hello everyone, welcome to today's math class. Today we have this challenge before us here. I've solved this challenge using two different methods already. This is making it the third one. As I promised in the first approach I applied the solving this, that I'm going to release two more approaches to solving this, and you tell which is the best for a student in case of the examination. So the question is bracket open square root of 3 plus the square root of 39 all over square root of 12 all raised to power 7. So how do we simplify this without the use of the calculator? Now, the second method I call that method the crude method of solving this. Okay, so I use binomial method in doing that. Okay, alongside with the Pascal formula in getting the coefficient of each term. Now, this approach is a kind of simple, but is longer. But at the end, you tell which is better for examination situation. Okay, so if you've not watched the other two methods, I'm going to leave a link in the description below where you get access to them. Watch them and then drop your comment in the comment section. So we have our solution. Now, in solving this, we're going to break this down, and I've done that in the first and the second approach. So we're going straight to the simplest form of this when broken down. So we have our square root of 3 there plus the square root of our 39, okay, there all over the square root of 12. When simplified down, will give us bracket open 1 all over 2 there plus the square root of 13 all over 2 close bracket all raised to power 7. So how do we simplify this without the use of the calculator? Now we're going to do a simple substitution to this quantity we have inside here. Okay, so from here we're going to say here let our x be what we have inside the bracket, which is 1 all over 2 there plus the square root of 13 all over 2. Let's call this equation 1. So since we have equation 1, what we do, we are looking for our x to the power of 7. What will now be the value of x to the power of 7? So from equation 1, we want to multiply both sides of this equation by 2. Why are we doing that? We want to eliminate these denominators we have here now, and there are 2. And so we multiply by 2. So if we do that, we're going to have our 2x is equal to our 1 all over 2 there times 2 equal to the square root of 13 all over 2 there times 2. Okay, so if we cancel out, this and this will leave, this and this will leave. So we are now left with our 2x then equal to 1 then what am I saying? Equality sign here. Sorry, here is plus, please. So plus here. So here we have here plus our square root of 13. So this is a radical. So let's move this quantity to this side so that the radical stays on its own. So we're going to have our 2x minus 1 is equal to the square root of 13. Now we have to eliminate this radical, and it's a square root radical, so we take the square of both sides of the equation. In other words, let's square this side of the equation and we square this side of the equation. Okay, so if we do that, this power will go with this radical. So if we apply our simple algebraic identity, we're going to have this side to be our 2x all raised to the power of 2, then minus 2 into the first quantity, which is this, times the second one, which is this, 1, right? Then we have here plus our 1 to the power of 2, right? Then everything will now be equal to 13. So if we open up, this is going to give us our 4x to the power of 2, then minus 4x, then plus our 1 equal to 13. Move this one to this other side. So we're going to have our 4x to the power of 2, minus 4x is equal to 13 minus 1. And 13 minus 1 will give us our 12. So we now have our equation to be our 4x to the power of 2 minus 4x equal to 12. So we can reduce this again. 4 can divide through. So 4, we divide this. We equally use 4 to divide this. We use 4 to divide this. So 4 here 1, 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 4 here we have 3. And so we're going to have this to be our x to the power of 2 minus x is equal to 3. Wow. Now, at this point, what we do here is this. We move this x to this side of this equation. So if we do that, we're going to have x to the power of 2 is equal to x minus, plus here, all right? X plus our 3. Okay, good. Now, this is what we're going to do here now. Remember, we are trying to look for the value of x to the power of 4. So we try to increase this power. And so we're going to increase this gradually. How? Let's square both sides of this equation. So if we square this equation, we're going to have x to the power of 2 all raised to the power of 2. Then x plus 3 all raised to the power of 2. Again, if we apply the law of indices, we say that when you have your a to the power of your m bracket n, this is equal to your a to the power of your m n. So we want to multiply these powers out. So if we multiply this power out, we're going to have x to the power of our 4 is equal to, we apply the algebraic identity again, which is going to give us our x to the power of 2, then plus our 2 into our x into our 3, then plus our 3 to the power of 2. So if we open up, we're going to have our x to the power of 4, then equal to our x to the power of 2, then plus 6x plus 9. So from here, we have x to the power of 2 here, right? And yeah, look at what we did here. We have x to the power of 2 is equals to x plus 3. But let me write it well. So here, from here, it implies that our x to the power of 2 is equal to x plus our 3. So let's give this equation 2. Okay, so this is our equation 2, right? So we want to put our equation 2 into this place here. So this is going to give us our x to the power of 4 is equal to x plus 3. So we have here x plus 3, there plus our 6x plus our 9, right? Good. So let's continue. Then from here, we can easily add up what we have, x and 6x here. So we're going to have this to be our x to the power of 4 is equal to 7x, then plus 3 plus 9 will give us our 12. Easy. Remember, we are trying to increase the power of our x. Okay, so again, we want to square both sides of this equation. So if we square this, it's going to give us our bracket being s to the power of 4 all raised to the power of 2 equals to our 7x plus 12 all raised to the power of 2 again. So if we square this is going to give us our x raised to the power of 8 is equal to, again, if we apply the simple algebraic rule here, we're going to have our 7x all raised to the power of 2, then plus our 2 into 7x close bracket our 12, then plus our 12 raised to power 2. Easy. Good. So we're going to have x to the power of 8 here. Okay, this x as the base number to the power of 8 is equal to, if we square this is going to give us our 49x to the power of 2, then plus, if we multiply everything we have in here together, this is going to give us 168x. So we have 168x plus, if we multiply 12 by itself, is going to give us 144. Right. So here we have our x to the power of 2. Remember from our equation 2, x to the power of 2, look at it here, is equals to x plus 3. So we're going to substitute for that in this expression. So we're going to have our x to the power of 8 is equals to 49, then bracket open, our x, the plus our 3, close bracket, the plus 168x plus 144. Okay, so we can use this to open up this, right? Good. So we have our x to the power of 8 is equal to, we use 49 to times x will give us 49x, there plus, if we use 49 to multiply our 3, that will give us our 147, then plus, here we have our 168x, there plus our 144. Easy. Then let's finish up with this. So we can add this and this together and add this and this together. And so if we add this and this together, we're going to have our 217x plus, we add 147 to 144, we give us 291. Mind you, we have our x to the power of 8 on this other side. Right. So what do we do? Look at our x to the power of 8 here. We're looking for x to the power of 7. So we just have to reduce this. How do we do that? We divide by our x. So let's divide by x. So if we divide through by x, we're going to have our x to the power of 8 all over just x. We equally divide 217x all over x. Then we equally divide 291 all over x also. This will go with this. This will be 1. One of this will go to give us 7 here. So we're going to have our x to the power of 7, which is what we are looking for, equals to 217, then plus our 291 all over x. So the only challenge we have here is that here we are still having our x here. But remember at the beginning, we said let x be something. Look at it here. We said let x be equal to 1 all over 2 plus root 13 all over 2. Okay, so if we simplify this, so we're going to put the whole of that value into this system here. So if we do that, we're going to have this to be our x to the power of 7 is equal to 217 there plus 291 times 1 there plus our root 13 all over our 2. Wow. So if we simplify this, then this is going to give us 217 plus 291 there times 2 all over 1 plus root 13. Wow. So we're moving gradually. So this is going to give us 217 there plus, if we use our 2 to multiply this will give us our 582 all over. Then we have our 1 plus root 13. So from here, we just have to rationalize this denominator. And before we do that, we just have to rewrite this because this is greater than this. So rewriting this is going to give us our x to the power of 7 is equal to 217 then plus our 582 then all over root 13 plus 1. So rationalizing the denominator, we multiply by the conjugate here. Okay, so this is going to give us our 217 the plus bracket open 582 all over root 13 plus 1 close bracket or bracket close here, then times our conjugate here, which is this. So we're going to have root 13 minus 1 all over our root 13 minus 1. Okay, so we're going to have our 217 there plus. We use this to find this is going to give us 5, 8, 2 root 13. Then minus our 5, 8, 2. Yeah, all over. This times this because it's multiply its own conjugate. This is going to give us our root 13 all raised to the power of 2. Then minus our 1 to the power of 2. You remember this rule, right? Good. So from here, we're going to have our 217 plus our 5, 8, 2 root 13, then minus 5, 8, 2, all over our 13 minus 1. Because this power will go with this power. So from here, we are now left with our 217 plus 5, 8, 2 root 13, then minus 5, 8, 2 all over 12. So we can find the LCM of everything. We use 12 to multiply this, and then we simplify. We use 12 to multiply this, but let's take the LCM first. The LCM is 12. So we use 12 to times this. It's going to give us our 2604. Then plus this will remain. Okay, let's bring this first. So we're going to have a okay, since I've written the plus here, so I have 8 2 root 13, then minus 5 8 2. Okay, so we can subtract this from this, right? So if we do the subtraction, this is going to give us our 2022, okay, all over 12, then plus, here we are left with 5 8 2 root 13 all over 12. So we can divide down, right? 6 can go into this, and 6 can go into this, 6 can go into this, 6 can go into this. So 6 here will give us 2, and 6 here will give us 3, 3, 7. 6 here, 2, 6 here, give us 97. So therefore, we now have our 3, 3, 7 all over 2, there plus 9, 7 root 13 all over 2. Presenting our answer, we will have our 1 all over 2 bracket 3, 3, 7 plus 97 root 13 close bracket. So therefore, and I'll say therefore, our bracket open root of 3 there plus root 13, sorry, 39 rather, root 39 plus root 39, all over root 12, all raised to the power of 7. Without the use of calculator, will give us 1 all over 2 bracket 3, 3, 7 plus 9, 7 root 13. Alright, so this is the third method. I said this is simpler, but it's lengthy. Okay, so this brings us to the end of this class. Thank you. Again, do not forget to drop which of the method you consider or feel better in the comment section. Bye. If you've not watched the other two methods, I'm leaving the link in the description below where you can have access to them. Thank you for staying by. Thank you for watching. Bye for now.